Okay guys, 7.5 is over trig identities and how we use them to simplify questions, solve equations, that kind of thing. Got a couple of goals I'd like to go through, so it'll probably be a few videos on this section. That's okay, we'll just chunk it into pieces. So what you need to realize is that here are the goals. Use trig identities to simplify and or solve expressions and or equations. And then I added in goal number 2 here, which is to understand the derivation of addition and subtraction rules, and that's for trig functions. Right here, this is your handy dandy trig function rule sheet. You've got your reciprocal identities, your relationship between tangent and cotangent. You've got whether or not they're even or odd functions, so these are by definition. Co-function identities, so these have to do with those phase shifts that we talked about in video 7.3. Then we have our Pythagorean identities. Here's the big one. We'll use that one more than any one of the others. Sine squared of theta, that's the big one. These two right here are equally as useful, but this is the one you'll use the most. Then we have our adding and subtracting relationships, and we'll come back and revisit those. And then we have our doubling identities. So these are the doubles, where it's that 2. Now, things to be aware of. IB likes to give you things in this form and have you put it back into this form. Okay, so they don't just want you to know it left to right, they need you to know it right to left, forwards and backwards. So feel really comfortable with this piece of the puzzle right here. It's a big one. So is this one. We will use these all the time. Okay, on to the big scary thing, which is derivation of the sum and difference identities. So I'm going to kind of zoom in here a little so we have a little bit better picture. I'm going to keep my eye on what's going on. So we're going to try to do the addition rule for sine, the addition rule for cosine. Here's the difference identity, and here's the other difference identity. So, okay, these are a little messy. I'm going to highlight the value d here because it's going to play a crucial role. And then here is that same value d right here. Okay. So we're looking at a triangle that has this angle right here. All right, and this angle right here is the angle theta. Let's say I call it, I don't know, 4 pi over 3. And this angle right here is the angle beta. Let's say it were 2 pi over 3. So if I wanted to know what this blue piece was worth, I could say that this angle right here is worth 4 pi over 3 minus the 2 pi over 3. So that's what this expression is right here. So this blue right here and right here are the same value. They've just been shifted to the right so that we're looking at the same triangle in different locations. Right here, I have one point at cosine theta, sine theta, and my other end right here is worth cosine of beta, sine beta. Now I've shifted it to the right, and I can say that this point right here, the terminal point of the vector or side of my angle, is cosine of theta minus beta. So that's that angle that we're going to be interested in. And here it is again. So remember when we were talking about 4 pi over 3 minus 2 pi over 3, we were talking about cosine of the end result of 4 pi over 3 minus 2 pi over 3 would just be pi over 3. Okay, so we're looking at the same two triangles. Now, from the first one, we're going to think about distance formula, which is just derived from Pythagorean theorem, right? Where we're looking at the difference in our y values squared plus the difference in our x values squared, summed and square rooted. So that's that right there. The difference of the x's squared plus the difference of the y's squared, got the sum, and then the total is going to be square rooted. Now we're going to do the same thing over here. This d right here and this d right here constitute the same value, so that's where we're going with this. So the change horizontally here is going to be from 1 to cosine of alpha minus beta, and the change vertically is going to be represented by the difference between sine of alpha minus beta and 0. And then we're going to square those. So that's where this one is coming from. So I've got this guy, and then maybe I'll put a box around this one. Okay. Because those two values are equivalent, I'm going to set them equal to each other and square. Okay, we're just following along here. And so I have this value here, this value here, this value here, and this value here. Okay, I'm going to now simplify and square all that out and make sure my letters match up appropriately. So that is all the black part simplified. There is all the blue part multiplied out. Here's all the red part multiplied out. And then here's the purple part multiplied out. So here's where things get tricky slash, I don't know, identity happy. All over this place, we're going to have cosines of a specific angle squared and sines of that same angle squared. So anytime I have a pair of those, cosine squared of alpha and sine squared of alpha, that is just a 1. So we're going to replace that. Okay, we've got another one here with cosine squared of beta and another sine squared of beta. I'm going to put those together right here. And then there's the other one. Everything that's left is going to kind of simplify out. So I'm left with this quantity and this quantity together, and they're going to pull that -2 out that's in both of those terms. I'm going to have -2 cosine theta cosine beta plus sine alpha sine beta. Sorry, I said theta and beta. It's alpha and beta. So that all becomes this pink part right there. Okay, I want you to redo the same thing on this side. We're going to be looking for our, oh, I'm running out of colors. I'm going to be looking for our 1s. And here's our other one. And then I'm left with this quantity here. Okay. So these two things become a 1, and 1 plus 1 is 2. And then this right here is just -2 of this quantity. And then I'm going to have a 1 and another 1 on this side. That's going to become a 2. There's that. And then -2 of that quantity. So if I were to simplify this out, subtract the 2 away, divide the -2 out, I'm going to be left with cosine of alpha minus beta is the same as this identity right here, which is one of the identities that was on the front sheet. Cosine of alpha minus beta equals cosine of alpha cosine of beta plus cosine of alpha times, I'm sorry, sine alpha sine beta. Okay, now this whole section right here, they're going to do the same kind of thing, only instead of doing positive b or beta, we're going to replace it with negative beta, and we're going to get a simplified version that gives us the cosine of alpha plus beta versus the cosine of alpha minus beta. So that's versus, those are not equivalent. Okay, so there are those two rules. And if you want to, you can do the same process to come up with the sign difference identity and the sign sum identity. So these right here are big ideas. That's where they come from. Okay, but how do I use them? That's where we're going next.